We all know AI is changing our world. It's revolutionizing everything from how we make art to how we develop new medicines. But behind all these amazing breakthroughs, there's a massive, hidden problem: the incredible amount of energy it takes to make it all happen. So let's get into it.
So, the big question we're really digging into is this: what's the hidden cost of this AI revolution? And we're not just talking about money. We're talking about power, as in electricity, and a massive search for efficiency that's forcing scientists to completely rethink what a computer even is.
And wow, this chart really puts it all into perspective. The human brain, the most incredible computer we know of, it runs on about 0.3 kilowatt hours a day. Barely anything. But an average GPU, the kind of chip that powers most AI, it tears through more than 12. That is an absolutely staggering difference, and it just shows you how far we still have to go.
This brings us right to the heart of the issue: AI's hidden power problem. So why? Why does training these gigantic AI models demand such an insane amount of energy? Well, according to Professor Murali Anavaram, it really boils down to three main things. First, just the sheer size of the AI model itself. The bigger and more complex it is, the more power it's going to need. Second, you have the size of the data set it has to learn from. I mean, think about it. Models like ChatGPT have to process billions of pages from across the internet. And third, it's the basic efficiency of the computer hardware that's doing all the heavy lifting. Okay, so how do we start to fix this? Well, the first set of solutions is all about the software. Basically, making the AI learn faster by fine-tuning its own algorithms.
One of the cleverest techniques here is called pruning. Essentially, what researchers do is they go into the AI's neural network and they find and just trim away all the unnecessary connections. By kind of narrowing down the pathways, the AI can learn what it needs to learn way faster and, most importantly, using a lot less energy.
Professor Masoud Pedram has the perfect analogy for this. He describes pruning as being just like cutting dead branches on a plant. You're just trimming away all the non-essential stuff, which makes the whole system healthier, more focused, and a whole lot more efficient. All right, another really smart software trick is something called quantization. Now, to put it simply, this means using a more basic language, fewer bits, to represent all the data. This cuts down on the amount of information the computer has to constantly shuffle around, and that directly translates into lower energy use and faster training times. It's a win-win.
But smarter software can only take us so far. It's only half the story. We also need to completely rethink the machine itself, and that means coming up with big innovations in both the computer hardware and the infrastructure where all this work actually gets done.
We know that GPUs are the absolute powerhouses for AI, but they are expensive, and man, they are hungry for energy. So, researchers are getting creative with a hybrid approach. They use the cheaper CPUs, which have tons of memory, to store all the model's data. Then, they call in the big guns, the powerful GPUs, only when they're absolutely needed for the really intense calculations. It's kind of the best of both worlds. Next up is something called edge computing. Instead of sending data on a long round trip to a massive centralized data center, the idea here is to do the thinking right where the data is being collected, at the edge. A self-driving car is the perfect example, right? It can't afford to wait for a signal from a server halfway across the country. It has to make decisions in a split second. This kind of local processing isn't just faster, it saves a tremendous amount of energy.
Now this is a really fascinating idea from Professor Bharath Raghavan: information batteries. The concept is simple, but absolutely brilliant. You do all the heavy-duty computing when energy is cheap and abundant, say in the middle of the day when solar power is at its peak. Then you store the results of all that work. Later on, when energy is more expensive or the grid is strained, you just use those pre-computed results. It's literally like storing energy, but in the form of useful information. How cool is that?
Okay, the solutions we've looked at so far are incredible, but some scientists are thinking even bigger. We're talking way bigger. They're not just trying to tweak the system we have, they're aiming to build a completely new kind of computer by reinventing the absolute fundamentals.
So the huge difference here comes down to the material itself. Our silicon chips today waste a little bit of energy every single time a transistor switches on or off. The future might be in superconductors, which use totally different materials and physics. The key takeaway is simple. Superconductors have zero electrical resistance. That means almost no energy is wasted and lost as heat. And the potential payoff here is it's astronomical. Superconducting electronics are promising to be up to 1,000 times more energy efficient than the tech we're using today. That's not a small improvement. That is a complete paradigm shift.
A total game changer.
And this brings us to what might be the most ambitious goal of them all, copying the human brain. Because when you think about it, our brain is still the ultimate blueprint for doing powerful and efficient computation. This whole field is called neuromorphic computing.
This quote really says it all, doesn't it? We've managed to build machines that can calculate faster than us, for sure, but when it comes to pure energy efficiency, our own brains are still light years ahead. So the ultimate dream is to build hardware that actually thinks more like we do. So how do you even start to do that?
Well, one of the key technologies that could make this possible is the memristor. These are these tiny little electronic devices, we're talking smaller than a virus, that are designed to behave just like the synapses in our brains. And the really revolutionary thing is how they handle information.
See, in a normal computer, data is constantly being shuffled back and forth between the memory and the processor. And all that shuffling wastes a huge amount of energy. Memristors solve this problem by combining memory and processing into a single unit. Just like a synapse in your brain, they process information right where it's stored, which makes them incredibly fast and unbelievably efficient.
So from smarter software and hybrid hardware to these wild superconducting circuits and even artificial synapses, the quest for energy-efficient AI is really pushing the absolute boundaries of science. And it all leads us back to this one final question. We know the brain is our best model for efficiency. So how close are we really to actually building one?